For years, Titanoboa ruled the prehistoric imagination, a 50-foot serpent so massive, so dominant, that nothing could challenge it. It was the undisputed king of the ancient swamps. Until it wasn't. Recent discoveries from the coal mines of Colombia and the sun-scorched deserts of India have torn apart almost everything we thought we knew about this creature. Its diet, its behavior, its so-called dominance, and the real reason it vanished were all wrong. What the fossils are now telling us is far stranger and far more unsettling than any movie monster we invented. The story begins in 2009 at the Sarajan mine in Colombia, a sprawling industrial landscape where heavy machinery strips away mountains of earth every day. Scientists were there looking for plant fossils, hoping to piece together a picture of an ancient ecosystem. What they found instead was something that had no business existing. A single massive vertebra emerged from the dirt. It was so large that researchers initially assumed it belonged to a prehistoric crocodile, a reasonable guess, given that crocodilians were common during that era. But back in the lab, the shape of the bone told a completely different story. This wasn't a crocodile. It was a snake. They named it Titanoboa sarajanensis, and the numbers were staggering. This animal stretched roughly 45 feet in length and weighed around 2,500 pounds. Picture a creature as long and as heavy as a full-size school bus, moving silently through murky water. It appeared approximately 60 million years ago, right after the mass extinction that wiped out the dinosaurs. With the giant reptiles gone, a massive power vacuum opened up in the food chain, and Titanoboa stepped in to fill it. The media went into a frenzy. People called it a land-dwelling Godzilla, a super anaconda, the ultimate predator. Because no skull had been found yet, scientists made educated guesses and filled in the blanks with what they knew from modern snakes. They pictured it stalking through dense forest, crushing everything in its path. That image stuck, and it was almost entirely wrong. The label made intuitive sense. Anacondas are the largest snakes alive today, so it was natural to assume Titanoboa was just a bigger version of the same thing. But new analysis of its bone structure and evolutionary lineage dismantled that comparison entirely. According to peer-reviewed research from the Florida Museum of Natural History, Titanoboa sarajanensis belongs to the Boidae family and the Boini subfamily. It was a true boa, far more closely related to boa constrictors than to anacondas. More importantly, it represented a completely separate branch of evolution, not a direct ancestor of any living snake. The bigger myth, though, was the idea of it as a land predator. When scientists built digital biomechanical models of its body, the results were humbling. A 2,500-pound animal without legs, moving across dry ground, would have been nearly immobile. Gravity would have worked against it catastrophically. Its own weight would have risked crushing its internal organs. The blood pressure required to pump fluid through a body that long, fighting gravity at every inch, would have strained its cardiovascular system to a breaking point. Titanoboa wasn't a forest hunter. It was something far more specialized, a deep-water ambush predator that spent most of its life submerged. The evidence is written in its bones. Its vertebrae were shaped to handle intense water pressure. Its ribs were unusually wide, suggesting enormous lung capacity, enough to remain motionless at the bottom of a river for hours. Its muscle fibers were dense and slow-twitch, built for patient stillness rather than explosive pursuit. Even its scales left fossilized impressions, showing a surface optimized for gliding through water with minimal drag. It wasn't a super anaconda. It was a submarine with teeth. Finding an ancient snake skull is extraordinarily rare. The bones are thin and fragile, and they typically crumble to dust long before any paleontologist can reach them. When researchers finally recovered fragments of a Titanoboa skull, the find rewrote the entire narrative. The teeth were the most revealing feature. Rather than the thick, recurved fangs associated with large constrictors, Titanoboa had rows of thin, hooked spikes, the dental signature of a dedicated fish-eater or piscivore. The ancient swamps of Colombia were filled with massive lungfish and heavily armored catfish, and those hooked teeth acted like biological Velcro. Once the snake locked onto prey, escape was essentially impossible. To swallow animals of that size, Titanoboa relied on extreme jaw mobility. Its skull bones weren't fused. They were connected by elastic ligaments that allowed the jaw to expand far beyond what seemed physically possible. This wasn't a constrictor in the traditional sense. While it was certainly powerful enough to crush bone, researchers now believe it primarily used a snap-and-drag technique. Strike, latch, and use sheer mass to overwhelm prey in the water. Its sensory system was equally specialized. Large nasal cavities suggest it could detect chemical trails dissolved in murky water, effectively smelling prey it couldn't see, and rather than heat-sensing pits, which would be useful for detecting warm-blooded mammals. It likely relied on sensitive vibration receptors tuned to the movement of swimming fish. In a world where almost everything was cold-blooded, that was the more useful sense. The skull didn't reveal a terrifying land monster. It revealed a master of an underwater world that no longer exists. For 15 years, Titanoboa sat unchallenged as the largest snake in Earth's history. Then, in early 2024, a discovery from a lignite mine in Gujarat, India, changed everything. Paleontologists unveiled Vasuki indicus, named after the serpent king of Hindu mythology, a creature assembled from 27 massive vertebrae that suggests a snake potentially matching or exceeding Titanoboa's length. We are talking about up to 15 meters of prehistoric predator. What makes this discovery especially significant is that Vasuki was related to Titanoboa. While Titanoboa belonged to the boa family, Vasuki was a member of an entirely extinct group called the Matsoidae. Two separate lineages on opposite sides of the planet independently evolved to the same extraordinary scale at roughly the same time in Earth's history. Scientists call this convergent evolution, and it suggests that the conditions for giant snakes weren't a fluke. They were a global phenomenon. Vasuki was built differently than Titanoboa. It was thicker and more cylindrical, apparently slower moving, and likely spent most of its time coiled and waiting rather than actively pursuing prey. It lived around 47 million years ago, when the Indian tectonic plate was actively colliding with Eurasia. Its ecosystem was crowded with formidable competition: prehistoric crocodilians, massive sharks, primitive whales. Yet it thrived regardless, and scientists attribute that to the intense Eocene heat, which allowed cold-blooded animals to sustain metabolic processes at a scale we don't see today. Taken together, Titanoboa and Vasuki don't represent biological accidents. They represent the upper boundary of what life on Earth is capable of producing when the conditions are exactly right. The secret to understanding these creatures comes down to one word: heat. Snakes are ectothermic. Their metabolism is entirely dependent on external temperature. In a cold environment, their systems slow to a crawl. In an intense tropical hothouse, like the Paleocene and Eocene world, their biology can sustain something almost unimaginable in scale. Climate models suggest that average yearly temperatures in the tropics during this period reached around 34 degrees Celsius, roughly 93 degrees Fahrenheit, significantly hotter than the modern Amazon. This wasn't a temporary heat wave. It was a sustained planetary baseline. At that scale of body mass, Titanoboa benefited from something called thermal inertia, a creature that large loses body heat very slowly, meaning it could remain metabolically active through the night, without relying on constant solar warming. It was, in effect, a biological battery, enormous enough to store heat across entire days. But size creates its own problems. As a snake grows longer, its volume increases far faster than its surface area. At 50 feet, Titanoboa's total mass was immense, while its skin, the primary surface through which heat escapes, couldn't keep pace. On an extremely hot day, a snake that large risked overheating from the inside, since it couldn't sweat or pant to cool down. This is almost certainly why these animals spent so much time submerged. Rivers served as natural radiators, pulling excess heat from their massive bodies. The Goldilocks zone for giant snakes required a world hot enough to fuel their metabolism, but wet enough to keep them from cooking. That world no longer exists. The planet has cooled substantially since the Eocene, and modern conditions simply cannot support a 50-foot predator's metabolic demands. The Saragen swamp wasn't a quiet paradise. It was an ecosystem of extreme competition, operating at a scale we have no modern equivalent for. Titanoboa shared its waters with Carbonomes, a turtle the size of a small car, with a skull as large as a football and a shell so thick it functioned as mobile armor. Fossil evidence, including bite marks matching Titanoboa's dental pattern on ancient turtle shells, suggests these two animals had violent encounters. The swamp also hosted several species of ancient crocodilians, though here, the power dynamic was reversed. A 6-foot caiman in a river patrolled by a 45-foot snake wasn't an apex predator. It was a meal. Even apex status had to be earned daily. Juvenile Titanoboas entered the world around 10 feet. Enormous by any modern standard, but deeply vulnerable in a swamp filled with adult crocodiles. Grow fast or become prey. There was no other option.